Welcome to another tutorial of ProfLearn YouTube channel. In this video, we're going to have a discussion on the elite revision of circular motion. So we are going to see what are the key features and the key concepts that you need to know as far as circular motion is concerned. So one of the aspects we're going to discuss here is that in circular motion, the object is moving at a constant speed. But what we need to understand is that around the circular path, the direction of that object keeps on changing. So which means that even though the object is moving at a constant speed, but also its direction keeps on changing. So you can be able to see on this diagram here is that at this point the object is moving that direction, at point 2 the object is moving down. So around the circular path the object keeps on changing direction, and for that reason we're going to say even though the object is moving at a constant speed, since the direction keep on changing, then it means this object is accelerating. Also we need to look at different formulas involved in circular motion, and you need to understand that angular displacement is the angle turned at the center. So which means that angles are measured in radians, but in circular motion we don't measure angles in degrees, they are measured in radians. And you need to understand that time taken for a complete revolution, a complete cycle, is usually called frequency, and usually it is 1/t. Frequency is equals to 1/t. So in this case you need to understand the rate at which the angle at the center keeps on changing. So that means angular velocity is given by angular displacement divided by time, and since the angle turned by one complete revolution is 2 pi, when an object moves a complete cycle it must have covered 2 pi radians. Then since it takes a time t to make one complete revolution, so it will mean that 2 pi over t is going to give us the angular velocity. So that means since we have mentioned that 1/t is frequency, then we can be able to write this as the angular velocity. So angular velocity can be given as 2 pi f. So very important aspect that you need to understand. So in circular motion A level for both IAL as well as CIE physics, you need to understand the relationship between linear speed and angular velocity. So in that case, the formula that connect velocity and the linear speed and the angular velocity is v is equals to r times omega, whereby omega is angular speed, which is 2 pi over t or 2 pi f, and r is the radius of that particular motion circular path. And also we need to understand that as r increases, v also increases. So we can be able to say v and r are directly proportional. The type of force that keeps this object in a circular path is what we call centripetal acceleration. Then once we have centripetal acceleration, we can be able to find the centripetal force. And centripetal acceleration is given by linear speed squared over the radius, or you can give it in terms of angular speed, which is going to be r omega squared. So which means you need to understand that this acceleration makes 90 degrees with the linear speed, or the centripetal force, which is always directed to the center, makes 90 degrees with the speed. Not this change, the speed does not change. What changes? The direction. Then centripetal force is the force that keeps an object in a circular path, and in this case we can be able to say centripetal force is given by ma from Newton's second law. Then if you use this acceleration that we have gotten from the previous section, you need only to say force is equal to mass times acceleration. So it will be mass times this acceleration, which becomes mv squared over r. Or if you multiply this second equation with mass, you are going to get mr omega squared. So those are the two formulas for calculating centripetal force from the two relations. So from these formulas, you may be given a question that's going to ask you how radius and centripetal force affect each other. We need to understand that when the radius increases, the force decreases. So if the radius doubles, the force halves. This is from the concept of all the aspect that is being seen here. Force and radius are inversely proportional, and also in this case, when we are using angular velocity, radius and force are directly proportional. So if the radius increases, also the centripetal force increases. All right, so need also to remember different areas, different concepts in this particular topic. You need to remember that centripetal force maybe is not a different force, yeah, but what happens is when you have different scenarios, then centripetal force is provided by the types of forces. When we are talking about a car that is negotiating on a flat corner, then we are going to realize that centripetal force is provided by the frictional force between the wheel and the road. And when we are talking about an object that is moving in around orbit, such as satellites, objects orbiting around the Earth, the centripetal force is provided by the gravitational force. So we can be able to point that out. You are going to be given question to do with the vertical circles. Then you need to understand that tension at the top, the tension and the weight, both of them are acting downwards. But at the bottom, you see tension is acting up and weight is acting down. So we're going to have maximum tension when the object is at the lowest point here. And in that case, the string is likely to break or snap when it's at the lowest point in this circle that we are having at that given point. So that is quite important to note that if an object is moving in a vertical circle, it's likely to snap at the lowest point. And how do you identify that? If you look at the formula that we are having at this given point, you realize that if you're going to take this on the other side, because this is centripetal force, this is the weight, and then if you take it on the other side, you're going to have tension is going to be mv squared over r plus mg. So meaning at the lowest point, this object is going to experience the maximum amount of tension. But at the highest point, we have tension and the weight, both of them acting downwards, which is mg, and that is going to be equals to mv squared over r. Then if you take this on the other side, you shall have t is equals to mv squared over r minus mg. So you can see the value you are going to have for the tension at the top is going to be less, but here you are going to have maximum tension, and that's why we're saying that when an object is moving in a vertical circle, it's likely to snap, it's likely to break at the lowest point. So we've come to the end of this particular tutorial. Take note of that cheat sheet I've added there. I'll wish you the best. See you in the next tutorial. If you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. See you in the next video.